Okay, 12.7, last one. Here we go. 12.7. All right, this one should actually be shorter than the last two, so let's see how we do with that. We're talking about common logs, natural logs, and change of base. A lot of different topics. Whoa, that was awful. A lot of different topics here. But this really won't take very long to do. Okay, so what is a common log? A common log is a log which has a base of 10. So if you just wrote log of x, that's what's called a common log. It is understood that if the base is not written here, that the base is 10. So this is the same thing as the log of x base 10. The reason that this is called a common log, or that 10 is the common base, it's actually what it's called, 10 is the common base of the log, is because um, if you think about it, just about everything that we do, especially with a metric system, is based upon units of 10. We count to 10, then we start over with our ones place. So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 11, 12, 13, 14. The ones places start over every 10 units. And, I have my own theories on that, but I'm going to assume it's probably because that when we started creating these number system, we have 10 digits on our fingers, so that became the base for which we counted by as humans. It could be wrong, but that seems to make some sense to me. So a common log has a base of 10. So if the base is not written, it is understood to be 10. This is what your calculators will do if you just find the button that says log and you do log of some value. So let's just say you typed in log 7. What your calculator is actually calculating is the log 7 base 10. And then you can actually just put that in your calculator and it spits out a value for you, which is in this case going to be approximately 0.8451. Most of your calculators have this ability very easily. Even most phones nowadays have the ability to do logs. If it doesn't, then obviously go to your calculator. They all have that ability. So find the log button, do log of 7, enter. It should give you 0.8451. All right, so let's just practice a few, just to make sure that you guys can find these in your calculator. So go ahead and plug in log of 10, log of 1,000, log, and this one will be a little more tough to plug in, of 1/10. You'll have to put this in a parentheses and then push enter. And then log of square root of 10. Now you can plug all these into your calculator, but if you're really thinking about it, you don't really need it. All the bases are 10. So this one, if it has a base of 10, is 10 to some power equals 10. Well, 10 raised to what would give you 10? Has to be 1. You plug that in your calculator, you should get log of 10 equals 1. Same idea here. 10 raised to some power has to give you 1,000. That one you might not know off the top of your head, but 10 cubed, oops, don't really want to write that there. 10 cubed is 1,000, so therefore the answer to that one is 3. 10 to some power equals 1/10. Well, the only way to get the reciprocal out of that is to make it a -1 power. So again, plug that in your calculator, it should spit out -1. And don't forget that the square root is the same thing as 1/2. So this is the log base 10 of 10 to the 1/2 power. I'm not rewriting it, but you can hopefully see that. Log base 10 of 10, the square root becomes a 1/2 power. So remember that if the two bases here, the base and the argument are the same, the power becomes the answer. And again, if you plug that into your calculator, log of square root of 10, it should spit out 0.5 or 1/2. So if we were given a problem that said solve for x, and you're given the log of x equals 1.2. Well, you might think, well, wait a minute, how do I do that? I don't have a base, but you do. Remember, the base is understood to be 10, so it's 10 to the 1.2 power equals x. 10 to the 1.2 equals x. And then you could go ahead and actually put 10 to the 1.2 power in your calculator, and it's approximately, let's see what that gives us, 15.8489. And that's just putting 10 to the 1.2 raised to the 1.2 in your calculator. So there's applications that we can look at, but we're going to save those for after we deal with the natural log. So what is this thing called a natural log? Well, for mathematicians, there's a really cool explanation as to where all this stuff comes from. I'm going to try and hold all that for you guys, but basically the natural log is based upon a base. It is a log with a base of e. So the base of a natural log is e. Now, we don't usually write it the log of x base e. This is the same thing as saying the natural log of x, which I know it's written ln instead of nl. Not exactly sure why or where that came from, but this is how the natural log is. If you go to find it on your calculator, it'll say ln. That's the natural log. If you see natural log or ln of x, the base is e. And remember that e, we'll put this over here, e is approximately 2.71. That's a good enough approximation, but we don't really need to know that part right now. Just know that the base is e for every natural log. And the reason that this happens, they call it the natural log because it happens so often in the natural sciences. E and natural logs occur so many times, they called it the natural log. It's a very special one because if you see this, the only possible base is e. There's no way you can have a natural log base 7. That doesn't make sense. So a log of x base e is the same thing as a natural log. They mean the exact same thing. So if you wanted to do, again, just practice in your calculator, if you find the ln button, typically it's where the log is, but it might be above it, like in blue or yellow, depending on what kind of calculator, so you might have to use the second feature to get to that. But if you find the natural log, just do natural log of 8, it'll spit out a value which is approximately 2.0794. So make sure you can find that in your calculator and know how to use it. Excuse me. Okay, same general idea. If we wanted to evaluate some things with natural logs, if we have the natural log of e to the 3rd power. Well, again, remember that the base here is e. So it's not written, but the base down here is e. So that would be e to some power equals e cubed. E to some power. As a matter of fact, here, let me do this. I'm going to write the base, which we don't usually write, but it's in red. So that says e to some power must give us e cubed. What does that power have to be? Well, e cubed would have to equal e cubed. So the natural log of e cubed is just 3. Again, the base and the argument are the same, so your answer is just the exponent. Okay, let's try one more of those. Slightly different form. The natural log of the fifth root of e. So remember that the base is e. Let's rewrite that so that we can see it. That's the natural log of e to the 1/5 power, rewriting that root as a power. So this is e to some power equals e to the 1/5. The bases are the same, therefore the exponent is the answer. So the reason that it's important that we understand the natural log part of this is because what if we have to solve an equation that has a natural log in it? You have to understand that the base is e. So if we solve the natural log of 3x equals 5, I need to solve for x. Well, while it's not written, I would suggest if you have a hard time seeing this, write the base of e in there. It helps. And then to solve for x, you're going to follow our pattern. E to the 5th equals 3x. We're going to change this into an exponential. So I'm going to write over here e to the 5th equals 3x. But I'm solving for x. I'm not solving for 3x, so I still have to do one more thing. I have to divide both sides of this equation by 3. Dividing both sides by 3 gives us e to the 5th over 3 equals x. This, while it doesn't make a lot of sense to most people, is an exact answer. That's an exact value. If you want the approximation, the decimal, which usually would make more sense to people, you would plug this into your calculator. So just do e raised to the 5th power, push enter, and then divide it by 3. So whatever you get when you do e to the 5th, push enter, then divide the answer by 3, and you should get approximately 49.4711. So this is the approximation. This is exact. Okay, and you will be asked for both of those two things in the homework assignments, and very well could show up on the final as well. So you have to know how to give exact and approximate answers to both. All right, one of the most common formulas that uses this stuff is for interest rates or loan rates or things like that, which follow what's called a continuous, compounded continuously. So a formula for that is A equals P e to the RT. That is for interest which is compounded continuously. Okay? So A, which is basically the answer, this is the amount that we're going to get out, can be found where P is the principal. I always forget if it's an LE or an AL. I think it's LE, principal. R is the interest rate, and T is the time. So if you're given these pieces of information, you can simply plug it into your calculator and find something. So let's just say, for example, that we're given that our principal, which is $1,600, that's the amount that we invest, at an interest rate of 9%. Boy, that'd be nice if we could really make that much. Which, don't forget, has to be written as 0.09 when you write a percent as a decimal. And we're going to invest this for a time of 5 years. And we'd like to see, if we invest $1,600 at 9% for 5 years, what we would actually have out at the end. So pretty much you'll just plug this right into your formula. So A equals 1,600, that's the principal, E raised to the 0.09 times 5. And this you can literally plug right into a calculator. So So don't forget, you should probably do the e to the 0.09 times 5. You can multiply the 0.09 times 5 first if it helps, and then do e to whatever that gives you. But when you plug all this stuff into your calculator, so again, make sure that you can actually figure this out, you should get about $2,509.30. Because of the fact we're talking about money, if this thing gives you a decimal past this, remember to round to the penny, because we're not going to go in units past that. So that would be the amount of money that you would earn, or that you would have out, if you invested $1,600 at 9% for 5 years. You would actually get out $2,509.30. It'd be really nice if that was the interest rate that we could get. I don't think you can get that anywhere nowadays. All right, last piece of information. Change of base. Change of base. All right, the main reason that we might need to do this is if the base is E, if the base is 10, you can plug these things right into a calculator. And while some of your calculators have this ability, some do not. Let's say you needed to figure out what the log of 3 base 5 is approximately, to get like a decimal approximation for this. Well, 5 to some power doesn't equal 3 very easily. I don't know what power that would be. This is not something that's going to be easy to figure out. So there's a formula that helps us to figure this out. And the formula says that if I start off with the log of A base B, if I go through what is called a change of base, what I'm going to do is I'm going to take this log and I'm going to change it into a common base. The easiest is to change it into a base 10, which is your common log, or to change it into a natural log, which is a base of E. It doesn't really make any difference what the base is, and that's kind of the nice thing about this, but since your calculators use base 10 and base E, it's easier to use one of those. So this says that I can take the log of A base B and write it as the log of A divided by the log of B. So notice that this bottom piece actually is the log of B. It's not a base B anymore. We're taking the base and actually taking the log of it. The way I always remembered it is this is the upper, this is the lower, so that's where they go when you change it. This is the upper piece, log of A. This is the subscript, which is the lower piece, and that's the log of B. I could write base 7 here, I could write base 10, I could write base 122. It doesn't make any difference. Your calculators will deal it in base 10, so you can figure that out. You could also do it as the natural log of A over the natural log of B. This just means that the two bases here are E, but they're the same base. So what we're doing is we're taking something that's not easy to figure out and doing what's called a change of base, changing the two logs by division into a common base of some kind so that you can actually figure out the value. So in this case, the log of 3 base 5 could be rewritten as the log of 3 divided by the log of 5. So be careful when you plug this one in your calculator, because you'll have to do the log of 3, enter, then divide it by the log of 5. Otherwise, you have to make sure you have parentheses ending this stuff, and just be careful on that. So if you do the log of 3 divided by the log of 5 in your calculator, you'll end up with 0.6826063. And that's probably way more decimals than we'd ever have to go, but that's the general idea. And one last thing that I would like you to try, just to make sure that you got the idea here, is to do this with using natural logs. So let's do, instead of log 3 over log 5, let's do natural log 3 over natural log 5. So go ahead and find that in your calculator, and you should end up with exactly the same thing that we had up here. So it doesn't matter what you do. So just know the change of base formula is the log of the argument over the log of the base, the upper over the lower, log of A over log of B, log of 3 over log of 5. And then you can actually find the decimal approximation based upon that value. All right, that is it. That is the O12 course. That's the wrap-up. So good luck finishing up the homework. Good luck on your final exam. Hopefully everything goes okay. Please do send me an email if you need something that either of the substitutes cannot help you with, and I will do my best to get back to you at my earliest convenience. Otherwise, I hope you guys have a great rest of your summer, and good luck in the future.